Hi everyone, welcome back. I hope you watched the last video on the topic of extracting TMA cores from a tissue microarray. If not, I highly recommend going back and watching it. And in this one, of course, I'll do a crash course of what we did in the last video, but it definitely helps if you watch the last one. And if you like this type of content, again, this is the time to hit the subscribe button. And while you're there, try to find the thanks button if you're feeling extra generous. Okay, so before any further delay, let's jump into this topic. What are we doing here? We are trying to actually work with the extracted TMA cores. Again, I'll walk you through quickly on how to extract these TMA cores from your .svs or CGI, whatever file that you have, using OpenSlide and QPath. And once you do that, you're in Python environment, right? You have a PNG file of individual core images. How do you perform color separation in the nuclei segmentation? And then from the segmented nuclei region, for example, get the intensity of the brown color versus the blue color or something. Basically the intensities ratios of cytoplasm versus, for example, the nuclei signal. That's just one example that I'm giving you, but it can be any other downstream analysis, right? So now I have actually done this color separation in the past. I'm going to use exactly the same code. So if you religiously watched all my previous videos, I apologize for a lot of overlap in the content, but of course, there is something for you to learn in every video anyway. Okay, that's a lot of talking. Let's go ahead and jump into the process of extracting the cores quickly and then performing the analysis. And I promise not to make these to be very long videos, so you're still staying focused throughout the video. Okay, let's jump in. And here is a 1-minute crash course on what we did in the last video. We used QPath to open our whole slide image. In this case, it's a .svs image. And then we went to TMA and TMA arrayer. And in our case, we have 16 fine and A through L. And we did the run to detect all these cores. And we also discussed why Python can be a bit challenging for this task. And once you're happy with all the cores, if not, you can move them. Once you're happy, you can just go to measure and where is show TMA measurements. It gives you the name, it gives you the position like A1, and then the X and Y coordinates. And we saved this as a text file, and this is the text file. We are going to import it into Python. In fact, we did that last week in our TMA array code right there. And we loaded the saved positions and we said, hey, from the centroid defined in the text file, go ahead and extract 3000 pixels around it and then save them as PNG. In fact, let's go ahead and run it because I may not have saved all of those core images, input images. Yeah, I got nothing here. So let's go ahead and save them. So let's run it and you will see that it is going through these one by one and it should save them in separate images like a1.png, a2.png. And these are all the high resolution images because we are we are saving these level 0 images that are the highest resolution images. Okay, let me go ahead and stop this. I think these are enough images for us to work with. And let's clear everything, all the variables, because we assume we have starting images anyway. Okay, so let's clear the screen. Everything is clean, and let's jump into the, by the way, let's look at how many images we have. We have about 9 images, right? I mean, you may have 600 images, such images. That's why it's important to automate things using Python, so you can start, walk away, prepare more TMAs, or send them to whatever the service lab is helping you out. Okay, so these would be the inputs, and let's store for each of those images. We want to separate the colors. We want to detect the nuclei. We want to calculate the intensities and so on. So all those, let's just save them in core results directory right here. So that is what the next 2 files are going to be. Instead of making one extremely large Python file, I just captured a whole bunch of reusable functions into one of these. So here we have analyze TMA core, which is basically when I call this, it's going to use some of the functions down here. It's very straightforward, right? I mean, what I'm going to use here is, again, this is inneralized TMA core. What does it do? It separates the colors and it segments the nuclei and filters the nuclei based on min max, because you may end up with a million nuclei, but not everything is a nuclei if whatever the segmentation method you're using is not doing a great job. But StarDist is a deep learning model that I'm going to use, which does an amazing job for the most part, but you may always have some nuclei here and there. Anyway, I'm going to filter them based on minimum and maximum size, certain sizes. And then I'm going to get mean and standard deviation of the brown intensity values from the nuclei locations. Yeah, once the nuclei is located, using the blue image, we are going to extract the brown intensity from the blue pixels where we have nuclei. I hope that's not confusing. All we are trying to do is, hey, what is the cytoplasmic intensity values, for example, from the areas where we have nuclei, if that makes any sense. Okay, color separate, we are just doing color separate only. I also have color separate followed by something else, right? So color separate, what are we doing? All this code, I'm just using a bunch of code that someone else already have written as part of a library here called, RGB to HED is the function I'm using, and it's from scikit-image. Scikit-image.color, you can convert a RGB image to HED image, where H, hematocrit, eosin, and the DAB signals can be separated. And here it's back from HED to RGB, if you want to do that. Yeah. So that's the function I'm using to actually separate the colors. Nothing fancy. I didn't invent anything new here. So that's what I'm doing. And then I'm just saving the HED as separate images. And filter the objects is something we already talked about. And by the way, we talked about, but how do you filter? You need to first measure what the size is. And that measurement is done by region props. And from region props, I'm going to get the label, area, diameter, intensity, and all that. And I'm going to use that area to or diameter to say, hey, these are the ones that I want, and these are the ones I don't care about, right, in terms of nuclei. Now, another function for brown intensity from nuclei, basically, you need to open the brown image. You need to open the labels where your nuclei are, and then just get the intensity from those locations. That's it. And I also, just in case, have a function to subtract the nuclei from the brown image. So you can just show the cytoplasmic image without the nuclei. So these are all helper functions that I'm going to import into this part of the code. And what are we doing here? Here, obviously, you see how I'm importing this file and then individual functions from there. And our path is input images. For each of these images, we're going to do something. And what are we going to do? Again, column labels, file, mean, cytosol, and all of this. This is basically what I want to save as an output at the end of it. These are all the things that we are measuring. At the nuclei location, what is the red intensity? What is the green intensity? What is the blue intensity? And from nuclei, what is the RGB? Because these are all like RGB images, right? So what is that? And I'm going to save them and export them as into an Excel file or CSV file. Okay, for each of these images, I was timing it for some reason. For each of these images, go ahead, and now I'm just calling the functions. That's it. We already did the bulk of the work earlier. So all I'm doing is, hey, go ahead and extract the original, save the original image, H brown image, filtered segmented image, and all of these other information, because we get everything by running the analyze TMA core function, up here, right? All the way at the top. And then all I'm doing is calling that and saving it, and that's pretty much it. Very straightforward. So let's go ahead and run it. Okay, I'm trying to make this, I'm trying not to rush it. If you think some explanation is needed for any of these, leave that comment down below, and I'll definitely answer the comment or create a new video, actually make, with all that explanations. Okay, so it's now working on a1.png, and it says color separating a1. You see how it created in the results, a directory called a1. And within this directory, it should save all the results except for the Excel file or the CSV file, because that gets stored at the end of all the images as a summary. Okay. Now I'm using, for segmentation, I'm using deep learning, and I'm using StarDist 2D and a pre-trained model called 2D versatile fluorescence. Even though it's designed for fluorescence images, it works great on these binary images. So that's what I am using right there. So it just downloaded it. That's why it's a bit slow. And it's going to segment the nuclei, and of course, separate the colors first, segment the nuclei, which is where it is, and then save the images any moment now. Okay, so it took a little longer than expected because I'm working on a system without a GPU. It does help speed up things, especially with the segmentation, right? If you have GPU. But as you can see, it started saving these images, and this is the original image. So let me go ahead and open it, and we'll end this. I mean, I'm going to show this only for one. Now it moved on to the next image, right? A2.png, as you can see on the screen. But if you look at these, let's expand this. Okay, that's the original image. And let's look at the next image, if I can go through it. Okay, let's open the next one. This is the H image. I'm trying to do too many things. My system is not happy. So that's the nuclei image, and you get an idea. So let's actually increase the size here so it's easy for you to see. Now let's go to the extra, yeah. So this is the nuclei image, segmented nuclei, and probably let's open this and have a quick look at it. There you go, each of these segmented nuclei. And then we also saved the ones brown without the nuclei and brown with the nuclei. And I'll just open this and stop right there. So you see how it's actually proceeding now. I don't want to waste anyone's time by doing all these images, but you get an idea. And also my computer seems to be dragging for some reason. You see, if I go all the way to 100% here or 200%, you should see this is an image where it only shows the cytoplasm and not the nuclei. Okay, so I seriously hope you learned something in this video, and if you want me to focus a bit more on these type of specific applications, just leave those in the comments. I read them. I may not have time to respond to every comment, but I do read them. So I'll see you in the next tutorial with a different topic, definitely focused on Python and possibly focused on deep learning topic. Thank you.